Hey everyone, let's start with another lecture video of CS2505. Today we are going to learn about C's strings. So, so string is not what you expect it to be in C. C doesn't have any classes, you already know that, and C doesn't actually have any actual string thingy. Okay, so in C, string is basically an array of character. Okay, so if you understand the lecture about arrays, then this lecture is going to make much more sense to you. So if you are studying it without looking at the array lecture, definitely go and check that lecture out before you start this. So yeah, in C, there is nothing called, there is technically nothing called strings. What you have is array of character. Okay, so from that, let's get started. So the main idea of string in C is it is going to be an array of character and it's going to end with a null terminator. The null terminator is very important. If you do not have null terminator at the end of it, it will always create very weird outputs. Okay, so most of the problems you will be facing whenever you are working with strings in C is you do not have a null terminator, and it will create way too many problems, trust me. So whenever you are getting weird outputs or anything like that, make sure the first thing you check is whether you have a null terminator at the end. The null terminator is basically the the character null. Okay, so it can be interchanged with this, which is already over here, or simply a zero or null. Okay, so they are the same thing because its value is basically zero. Okay, so that's how it works. And whenever a character array ends with a zero, it turns into a string. Okay, then you can use it as a string. So let's take a look at this example. So we have a variable called word. It is a character type and it's an array. So it's going to be a string. And if you write it like this with double quote, remember in C, if you put double quote, it's going to be a string. If you have one quote, a single quote, it's going to be a character. Okay, a character should not have more than one character. Like, it shouldn't be like this. This is wrong. If you are going to use two or more characters, it should have double quotation. Okay, and if you are initializing it with double quotation, you can assume that there is a zero at the end. There is a null terminator at the end of it. Okay, so in this case, if we break it down, this is where we put like full bar, and at the end of it there's going to be a zero. So whenever you are working with string, make sure you have one additional space for the null terminator, because the word over here is size of 6, right? 0 1 2 3 4 5, sorry, 1 2 3 4 5 6. So why is it 7? Because we need an additional place for the 0. This is very important. If you do not have an additional space for the 0, it's always going to give you garbage output. Okay, C treats character arrays as special case in number of ways. If storing a character string to use as an unit, you must ensure that the special character, the string terminator or null terminator, is stored in the first unused cell. Failure to understand and abide by this is a frequent source of errors. Okay, so it will always end with a null terminator. You should, or string terminator. You should always make sure of that. Okay, so time to time I may call this string terminator as null terminator. You can just like think of them as interchangeable. Okay, and remember, this is can be replaced with 0. So sometimes you may face some problem. You can bring it to me and I will say that put a 0 at the end. It basically means that either you can put the character or the number 0. They mean the same thing. Some string library functions. So even though string technically doesn't exist in C, you still need some library functions to work with it, right? To make things easier, or you can write it by yourself. So you have the header file string.h, And whenever you include it, you have a collection of functions that you can use to work with strings. So the first of them is memory copy. So what memory copy does is copies in bytes, which is stated over here, copies in bytes from the object pointed by S2, this is the source, into a object pointed by S1, which is the destination. If copying takes place between objects that overlap, the behavior is undefined, returns the value of S1. Okay, so if you want to copy something, okay, so I said something like pointed by, right? For now, think of them as array. When in pointer, it will make more sense to you, and pointer is literally the next lecture video. So just whenever I say pointed, I basically means it's an array. Okay, so how memory copy works is, this is the destination, this is the source, and this is number of the characters in a string. Okay, so you do not have to write something like, for example, I have a character array, which is like hello, and then I have like character array world. Okay, so if I want to copy the content of this to this, I do not have to write something like memcpy ab10. Okay, I can just write it this ab10 and it will still work. You shouldn't be doing this. There is some problems if you try to do it like this. You should always be using it like this, okay? Because we already know that the destination is going to be replaced by the source. That's how it works. And you already know that arrays are called by reference, not called by value. So whatever array you are sending as the parameter is going to be changed after the function returns, okay? Make sure that makes sense to you, because like that is one thing many students try and get wrong. So memory copy is potentially more efficient than a user defined loop. You can write a loop by yourself, but it will most of the time not be as efficient as memory copy. So memory copy may trigger a segfault error if the destination region specified by S1 is not large enough to allow copying in bytes. In bytes cannot be copied from region specified by S2. Many times that can happen. So the interface of memcpy. The memcpy interface employs a few interesting features. First, the void pointer says nothing about the data type to which S1 and S2 points to, which makes sense since memcpy deals with raw bytes of data. So it will actually work with integers as well, double as well, as long as they are in an array. Okay, so even though we are talking about string, it can work with everything else. Restrict implies more or less that no pointer is the same context points to the same target. Here, restrict implies that S1 and S2 do not share the same target. That implies guarantee that the implied guarantee cannot be verified by the compiler. This is of an interest mainly to compiler writers. It is more of a convention or something like that. You don't have to worry about it. You will probably never use it in your whole life, but it exists, okay? So, and there are functions that support the operation of C strings, including strcopy. So we saw that memcpy, strcopy kind of works the same way, but it doesn't have the in, right? It doesn't have the size specified. So copies the string pointed by S2, including the terminating null character, into the array pointed by S1. If copying takes place between the objects that overlap, the behavior is undefined. Return the value of S1. Once again, whenever you're using strcopy, you should just like write A, B. You shouldn't be writing A equals strcopy A, B, okay? So another thing to point over here is, again, this is the destination and this is the source. Okay. str copy execution depends on several assumptions. First assumption is the string pointed by s2 is properly terminated by null character. Okay, if it is not terminated, like if it doesn't have a null terminator, it's going to create some weird problems. So once again, that is a very important thing to check whenever you are working with strings. The array pointed by S1 is long enough to hold all the characters in string pointed by S2 and a terminator. Okay, so they should be of the same size or more than S2. That is an assumption that is being made over here. strcopy cannot verify either assumption and may produce serious errors if abused. I mean, if you're not checking whether these are taken care of, it will create some weird errors. C string library hazards. The memcpy and strcopy function illustrate classic hazard of C library. If the target of parameter S1 to memcpy is smaller than n bytes, the memcpy will attempt to write data past the end of the target, likely resulting in a logic error and possibly a runtime error. A similar issue arises with the target of S2. The same issue arises with strcopy, but strcopy does not even take a parameter specifying the maximum number of bytes to be copied. So there is no way for strcopy to even attempt to enforce any safety measures. Worse, if the target of parameter S1 to strcopy is not properly terminated by 0, then the strcopy function will continue to copy until a 0 byte is encountered or until a runtime error occurs. Either way, the effect will not be good. So this is creating very weird outputs. This will, you can give it a try, like have a source that is bigger than the destination and try doing strcopy or memcpy and see what happens. You can also try doing like making a string that doesn't have a null terminator and try copying it and see what happens. Okay, so these errors are very weird. You will face them for the rest of your life, and there is no checking by the compiler itself. It's something the programmer has to be aware of. Later on, like for Java or Python or whatever programming languages that are popular right now, they take care of this. Like they are not like, okay, we are just going to believe in the programmers. They believe that programmers can make mistake, and they have made sure that this type of error does not occur. But C is a very primitive language and it is very ancient and old. So what happens is this type of checking were not made. So you have to be very careful whenever you are working with it. So there are some safer copying. It kinda is same as memcpy, but like not really. Let's see. We have strncopy. Copy is not more than n characters from the array pointed by S2 to S1. If copying takes place between the objects that overlap, the behavior is undefined. If the array pointed by S2 is a string that is shorter than n characters, null characters are appended to the copy in the array pointed by S1 until n characters in all of them are written. Return of the value of S1 just like before. Of course, strncopy must trust the caller that array pointed by S1 can hold at least n characters. Otherwise, error may occur or not occur, and it will just give you weird output. And this still raises the hazard of unreported truncation if S2 contains more than n characters that were supposed to be copied by S1. Null terminators of the destination is not guaranteed in that case. Give it a try to copy less than n, like less than the length, and see what happens. Another string library is strlen, which you will be using. So I said that array doesn't have any like size or like length function, but you have a function to calculate the length of a string, which is strlen. This is a very important function. You will be using this a lot. It computes the length of the string pointed by S, returns the number of characters that precede the terminating null character. Hazard: if there is no null character of strlen will keep reading until it reaches a point where there is a null character. For example, your string kind of looks like this: A, B, C, and there is some garbage, but you just wanted it to stop here. Okay, and then it finds a 0. Then it will tell you that it is length of like 1000 or something like that. So how it works is, it is a very simple loop call. It like loop, it is just like A, B, C, and whenever it finds a 0, it returns the number of character it read. So over here it would be 1, 2, 3. So it is just going to return 3. So whenever it reaches a 0, it's going to stop. And one thing to point over here is, with 0, I do not mean this 0. I mean this 0. There is a difference between these two. Okay. So whenever it finds this 0 or this 0, it will stop and it will return how many characters it had actually found. Okay, so that's how strlen works, and that's why strlen can find the length of a string, but there is no length for array, because there is no convention of what is going to be the end character of a array. But there is a convention of string or character array that it's going to end with a 0. Okay. There is also the function strcat. What it does is, it basically concatenates. Okay, so strcat appends a copy of string pointed by s2 to the end of s1. Okay, the initial character of s2 overrides the null character at the end of s1. If copying takes place between the objects that overlap, behavior is undefined. So it is basically like you have the string ABC by S1, and you have like DEF by S2. If you called strcat with S1 and S2, the output is going to be, S1 will be now A, B, C, D, E, F. So there is something very important that you have to make sure over here. S1 needs to have enough space so that it can have DEF plus a null pointer, sorry, null character. Okay, that is very important. Otherwise, it will not have any place to put those, and you will have some sort of error. And yeah, that is very important thing to point. Like notice whenever you are working with strcat. There is also a version of strncat where you actually specify how many characters are going to be read from S2. Okay. There is another function strcomp, and whenever you are actually comparing two strings, you should make sure that you are actually using strcomp instead of trying to do equal equal. Equal equal doesn't work with strings in C. It may work with some other language such as JavaScript, but in C it does not work. It is kind of similar to dot equals in Java. Okay, so how it works is it compares the two strings you have sent. The first one is S1, the second one is S2. It will compare them, and if they are equal, it will return 0. Okay, if S1 is actually greater than S2, which is if it is greater than in terms of like lexicographical order, in that case it is going to return 1 or any positive number. Maybe it is greater than, like if S1 is greater than S2 in lexicographically order by 4, then it's going to return 4. Okay, and if S1 is actually less than S2, then it's going to return some minus value. Okay, give it a try by yourself. Like try to compare a bunch of strings of your own and see how they actually what value it actually returns. But remember, the most important part is if you want to compare whether two strings are equal or not, you should always use strcomp. You should not be using equal equal. Okay, equal equal doesn't work for string. You have to use strcomp. That is a very important like note about C, because this is a very common mistake most of the students make, and I don't want you to be making the same mistake. There is a version of strncomp as well. In this case, we actually specify how many characters that are going to be compared. In this case, it's going to compare all of the characters, but in this case, it's going to stop after it finds the nth character. So here's an example of a bad strcpy. This code is given in the GitHub. Give it a try. So we have over here S1. S1 is the size of this, but S2 only has size of 1. And when we try to copy S1 to S2, if we try to print it, well, it's going to give you a very weird output. Give it a try and see what happens. Okay. In my case, this is what the output look like. For you, it may look a very different way. Okay. Again, like I said, give it a try and see what happens. And it will give you an idea of why it is bad to have, like not enough space when you are copying a string. This stuff you have to make sure by yourself. The compiler or the OS is not going to help you much on this one. Here is a example of a duplicate string. It is kind of like strcat. So this will not make sense much to you because we didn't cover pointer yet. You can come back to this part again later when you learn pointer, and it will make much sense to you. So I'm going to just like glance it over for now because it will not make much sense right now. Okay, I'm just giving it to you so that like later on you can come back here and you'll be like, oh, now it makes sense. Okay, but for now let's take a look what happens. So we are creating a array dynamically. We already covered that in the array. So instead of malloc, we are using calloc, and then we are just running a loop for that. Okay, we are basically copying str to cpy one by one by running a loop, and whenever it finds the 0, it's going to stop. Okay, this is a very common C code, and this is just like writing it down, like dividing every step one by one. But this whole part can be just replaced with memcpy. Okay, you can also use strcopy, strcopy or strncopy if you want. They work the same way, but you know what type of hazard that may cause, so be careful whenever you're using it. There is also the trunk string. It's just a example. So we are just running till a 0, and if we find the specific character that we wanted to find, we are going to return true. Otherwise, we are going to return false. Again, this code is in the GitHub. Take a look at it if you want. And one way to iterate string array, like string, is to do this. Okay, a while loop that runs till it finds 0, and we are going to do idx so that it goes one by one to each character. Another way to iterate string is to write a for loop. For int equals I less than strlen, in this case str I plus plus. Okay, these are very common ways to iterate through string. You can use either of one of them. You can make use of the fact that a string ends when there is a 0, or you can just make use of the length. Any of them is feasible. There is another way. In C, whenever a value is 0, it is considered false, and if a value is non-zero, then it is considered true. So you can write something like while str index. So we already know the fact that the last character is going to be 0, right? And we want the loop to stop whenever we find a 0. So we can just write something like this. Oh, wait. Yeah, we can write something like this. So as long as the value is not 0, the loop is going to keep going. But make sure you have the index plus over here. Otherwise, it's going to be an infinite loop. Okay, so this is one way you can actually write. This is 3 ways you can actually iterate through strings. whichever you use is totally up to you. There is no specific convention you have to make sure in this case. Okay, so C strings and IO. The basic nature of string handling in C causes some problems with the input of strings. The fundamental problems are strings are stored in array of characters. These arrays are fixed length and must be created before input is read. Input may be unpredictable. Output and C strings. Assuming a properly terminated C string, writing it to a file or standard output is simple and safe. The most common approach is fprintf, which you have already learned by now. You are already using it in an assignment as well. With properly terminated string, this operation cannot fail unless the output device is full, which seems unlikely because we have way too much memory these days. There is other like printing option you have, like sprintf or snprintf. There is an example over here. You can try this and see what type of output it is making. But if I have to explain it, so what it does is, instead of printing this thing in the terminal, it's going to copy it over here in str2. Does that make sense? Like in fprintf, you actually put a file pointer over here. Over here, you are just putting a array, character array, and whatever was supposed to be printed in the terminal or in a file is going to be copied in this string or like character array. So this is something you can make use of. There is also snprintf, where you actually specify how long the length is going to be, which is the second parameter. Okay, so fscanf, you have already used fscanf before, so it should make sense to you by now. Fscanf will skip leading white spaces, you know that. Read and store characters into str until white space or end of the file is encountered. Write a terminating 0 at the end of the str. Okay, so fscanf is also very like safe to work with, but remember, fscanf has no information of the length of the string. Okay, so it may write past the end of the array. So fscanf has no information that this particular string, the length of this particular string. Okay, it could be like over here it's like 25, right? But when you are reading, it could be the size of 100, and it doesn't know that. It's still going to try put everything there, and we know what type of problem you face when that happens. This is arguably more safe than other options you have. You have like fgets and all of those. I'll be mentioning them shortly. Compared to those, fscanf is probably the most safer option you have. Okay, so if we want to read something like this, you have already done assignments of this manner, so it should make more sense. It should make already sense to you. Like if we want to match this pattern, we know how to do it. We just put the tab in the format specifier, and it's going to copy everything. So give this code a try. I think it is in the GitHub already, so we know how to make it work. There is also like you I mean, honestly, I already feel like fscanf should already make sense to you, and right now we are just like working with the strings like officially. Okay, all right. Yeah, you only work with fscanf with probably just like numbers and stuff. Now you're looking at the string, right? So it works more or less the same way. And in this case, we are using the %s specifier. There is other options like bracket, and in that you write some sort of regex. That is a very advanced level of information. If you want to know more about it, you should take a look at the documentation of fscanf. But otherwise, if you just use %s, it is going to cover most of the stuff we are going to cover in this course. And %s basically stops whenever it finds the space. That's it. Now try to give this a run and see what happens. So we know that like this one is not going to work because it is way beyond 25 and it's going to create some trouble. Give this code a try and see what type of trouble you are actually going to face. Okay, so things will seem okay, but here's the output of the given code. Like if you try to run it, this is what it's going to look like. And let's add some printf statement to check whether the string after everything has been read. If we try to print it, we see that apparently reading that long place name has caused array holding the last name to be corrupted, while the tail end of the long place name, there is no runtime error, just incorrect results. So this is what happens, like it starts replacing everything. It doesn't care like whether there is something over there or not. It's just going to keep going. So you should always make sure that whenever you're working with string, you have to make sure that you have enough space to copy whatever you're reading. So using fscanf to read character data can lead to some silent errors. It can also lead to runtime errors. If we merely change the placement of the array declaration in the code shown earlier, and we will see that there is some sort of like segfault. So using fscanf to read character is clearly risky, but it is still safer than most of them. Okay. And there is another example. We will try to read this as well. You can give it a try by yourself instead of looking at the code I have given to you. It is already in the GitHub, so if you get stuck, try it by yourself. So we have a file where we have this, then there's going to be a tab, then another name, another tab, and then some sort of specifier, like specific input, right? Like what time it is, like, sorry, it is the time of the song track, like how long the track is. So you can actually use other functions like fgets instead of fscanf, but remember fgets is not safe at all. Okay, I mean, it is safe, but like fscanf is definitely safer than this. Fgets can be used safely runtime to read the entire line of characters if we have reasonable idea of maximum length of the line. If we do not have idea of how big the line can get, it is going to create a lot of errors. Okay, strtalk is a very interesting function. Strtalk can be used to break up a character into like character string into chunks based on the occurrences of uh, delimiting characters. It is kind of similar to split in Java, but it is more primitive, and honestly strtalk is kind of hard to work with. There are very good examples online. I'm going to show you how to do it by over here as well, but this is something you should try by yourself to understand better. Okay, because there are many variations of how strtalk is used, and I honestly cannot show you every version of it. This is something you have to try, like learn by trial and error. Okay, so let's try to do it with fgets and like strtalk. So this is what the fgets looks like. So fgets has a parameter s, and number of like how many characters we're going to read, and then the name of the file. So what fgets does is it reads the bytes from the stream into an array called s, which is over here, until n-1 has been read or a new line of character has been read, okay, or an EOF is encountered. S is then terminated with a 0 byte. Basically, a null terminator is put at the end. Return S on success, return null if the error, like if there is any sort of error or no data was read. So how it works is fgets actually reads the whole line instead of stopping whenever there is a space. So that is pretty interesting, because we know that when we are using fscanf, we know that it's going to stop whenever it finds a space. But fgets reads the whole line. It will only stop when there is a new line or a end of file. Another thing to notice here is like fgets also can work like this. In that case, you have to use the bracket thingy that I mentioned. And by using that, you can actually make fscanf work just like fgets, but like usually if you want to work with a full line, you should be using fgets because it's much easier to use. Okay, so this is how we are going to read a whole line. We have fgets data, which is the size of this. We are specifying the size so that it doesn't go beyond that, and we are specifying the file name which we open somewhere. Look at the code and you will see the full version of it. Okay, and at the end we are checking whether it is equal to null or not, because we said that if there is some sort of error, it's going to return null. So we are going to keep reading it till there is no null, and when it reaches the end of the file, it's going to return null, and in that case this loop is going to stop. Okay, then now we are going to use strtalk. So strtalk has two parameters. The first one is a string, the second one is the list of the delimiters, and both of them are actually strings. Like this is also a string, this is also a string. The character star is equivalent to character array. Okay, so if s is not null, if we do not send null as a parameter, searches s for the first character that is not in the delimiters, returns null if this fails. Otherwise, notes the beginning of a token, searches s for the next character that is in the delimiters, replaces that with the terminator, and returns pointer to beginning of the token. And if s is null, performs action as above using the last string is passed in, beginning immediately after the end of the previous token that was found. It probably didn't make any sense, right? So I will try to give you an example that makes more sense. So for example, we have a string like this: ABC, DEF, GHI, and then a dot. Okay, so first we are going to call strtalk. Imagine this string is this, like x. Okay, so we are going to call it like this, x, and then we are going to specify our delimiters. We are going to specify comma and dot as our delimiters. Okay, so I will give it a call, and what is going to happen is it's going to keep reading till there is a comma, which is over here, and then put a 0 over here instead of a comma, and then return this as the return type, which is a character pointer. Okay, so the first output of strtalk is going to be ABC. Now if we call it with strtalk null and the same delimiters, which is comma and dot, okay, in that case it's going to start from here. Now it's going to read DEF. I'm going to stop here, put a 0 over here. So now our new output is going to be DEF. Then if we call it again, it's going to return GHI and going to stop. Okay, so another thing to notice over here is we are saying that it actually replaces these delimiters with zeros, right? So whenever you're using strtalk, make sure you are making a copy of the string, otherwise that string is going to be lost. So in our example that we were explaining, this is what is going to happen. Suppose the first line of the input is like this. So the contents of the array is going to be this, right? If we use strtalk with the tab character, what it's going to do is it's going to keep reading and stop here whenever it finds the tab. Okay, so it's going to put a 0 over here, and next time we call it with, sorry, my bad. So we said that our delimiter is tab, so it's going to go to the place where the tab is, the first tab is, not here. It's going to come here and put the 0. Okay, and then it's going to return this as an output. The next time we call it with the null instead of the string, it's going to go to the next place where there is a tab and then put a 0 over there. Okay, so that's how it's going to happen. Give it a try and see what happens. Okay, sometimes strtalk is actually used in a loop, And if you search for it in internet, the first thing you're going to have a Geeks for Geeks website link, and it actually gives a very good example of like how strtalk works. You can make use of it, but remember, strtalk doesn't work with empty strings. So if there is an empty string, it's going to act very weirdly. Give it a try by yourself and see what happens. Okay. So to copy the string like token, we are just going to use strncopy. You can use memcpy if you want. And once again, calloc is basically creating a dynamic array. Right now, it may not make sense. Just think of it as token length plus 1. Just think of it that way. In the next lecture, it will make much sense to you. Okay. Reading the following data. Each input line has the length field time after the title field. This numerical data should be read as such. The interesting part is how to get a pointer to the beginning of the length field. So we can actually make use of strlen for this, or we can just use strtalk for that as well. It's up to you how you want to do it. You can also use fscanf, which basically works like scanf, and we already seen how to read data like this in our previous lectures. So you can give it a try by yourself. You can actually specify this star. Star means just ignore whatever there was. Like for example, there is a colon over here. You can just like use the star to say that maybe there is something there, just ignore it. So if we put this together, this is how our code is going to look like. It is given in the GitHub. Take a look at it, see if it makes sense to you. If it doesn't, let me know whichever part didn't make sense. And if you are ever stuck with the calloc, just wait for the next lecture. It will make much sense to you. Okay. So that's it for this lecture. I tried to explain as many stuff in string as possible. If you have any if you didn't understand any part of it, just let me know. I will try my best to explain as much as I can. And the best part to best way to actually learn it is to try it by yourself, because if you do not try it by yourself, many of these concepts won't make sense to you. There will be assignments where you are forced to try this by yourself, so don't worry. Still, after going through this lecture, play around with string functions a little bit and see how they react and whether it makes sense to you or not. And if they do not make sense to you, of course, I'm here for that. Just let me know. I will try my best to explain everything that is happening. Okay. So yeah, I'll see you in the next video.